Okay, so I also agree that if we can use it up in space, can we use it here on Earth? Because not everything must be used in space. You said that this library that you're working on will be to help countries in need to to provide them with medical supplies so they can bring them on site. Can you elaborate a little bit on that?
Sure. So, yes, there are many circumstances in which you don't have the medical supplies you need here on Earth, particularly in a disaster setting. But there are also places that are just really remote and isolated and just won't have the full inventory of medical supplies and devices that would be needed to cover all medical scenarios. So the question is, and what I'm really interested in, because I'm a physician who trained in public health, and I'm very interested in improving the health of populations, is can we take 3D printing technology, which we're using for space missions, and help people here on Earth? And I think the answer is maybe. I think it's exciting, it's worth exploring, and so there are good things about 3D printing. The good things is that you get personalized, on-demand, and on-site production capabilities, like having a little mini factory on your desktop. So it would be nice maybe that perhaps someday every temporary or permanent medical facility has a 3D printer, which has this digital library of 3D printable medical supplies. So those are the good things about 3D printing. As well, people are actually able to recycle failed 3D printed prints and recycle those back into printer material. But what's really exciting is that people are actually working to develop ways to recycle plastic waste into printer material. So imagine if you could take that plastic water bottle that you normally just throw away, that ends up in our oceans or in landfills somewhere, and then convert that into printer material.
Reuse it over and over.
Yeah, and make it into 3D printed into a medical supply, or a spare part or tool. That's really exciting.
I'll just reprint the same bottle.
Or you can do that too. Or just reuse it, just
Yes.
wash it and reuse it. So, but there are some downsides to 3D printing, which is why I think it's worth exploring this technology.
Okay,
okay. Yeah, you need to.
Więc biblioteka, nad którą pracuje Julie Lin, właśnie ma nie tylko służyć tam wysoko w kosmosie, ale również tutaj mówimy o pewnym spin-offie technologii kosmicznej, która może mieć tutaj świetne wykorzystanie na Ziemi w postaci takiej, że jeżeli mówimy o kraju czy miejscu na Ziemi, który nie może mieć pełnego szpitala z pełnym wyposażeniem sprzętowym, taki szpital czy miejsce, w którym właśnie odbywają się pewne procedury medyczne, mogłoby być wyposażone w drukarkę 3D i cyfrową bibliotekę danych. I w takim momencie, kiedy potrzebne jest dane narzędzie, tutaj inny element, taki lekarz czy medyk mógłby po prostu wydrukować je na żądanie. Co jeszcze ciekawego powiedziała Julie Lin nam, że może pracuje się obecnie nad drukarkami 3D, które mogą używać materiał z recyklingu. I mówimy tutaj na przykład o plastikowej butelce, którą zamiast wyrzucić do śmietnika, która może trafić gdzieś w niepożądane miejsce, takie jak znajdujemy często w wodzie, w lesie i tak dalej, może być ponownie wykorzystana do wydrukowania innych narzędzi 3D. So I must say this is great, and I really hope that it will work because I'm a huge supporter of ecology, and I think we should try to do something to really minimize amount of waste we produce. So if 3D printing is one of them, I will fully support this concept. But okay, we are talking about 3D printing, yay, great, and so on. Is there anything, any drawbacks?
Sure.
No, yeah.
No, I think that's a great question. There's drawbacks to any technology. So I see a few drawbacks to 3D printing. One is that, so let me just backtrack a bit here. Let me explain how 3D printing works. So you have a desktop 3D printer, you have a plastic strand that feeds into a printer head.
Yes.
And that printer head heats up that plastic so it melts. And that printer head moves around and deposits that liquid plastic onto a platform. And then once the horizontal layer is finished, that platform drops down, and that printer head adds the next horizontal layer. And it goes on and on like this until you have the final three-dimensional shape that you want.
So it's like additive, they call it additive manufacturing.
Exactly.
Because you add layer by layer.
Exactly. So now, That's great because unlike subtractive manufacturing where you start off with like a big lump of clay and if you're trying to make a sculpture and yeah, you take stuff away, that's kind of wasteful. So with additive manufacturing, in theory, you're only using the amount of material that you need to create something.
Okay.
But you have these horizontal layers and that is a weakness to 3D printing. So let me explain to you what that means. So imagine that this brick wall here is a 3D printed object. And each horizontal brick level is like a 3D printed layer.
Yes.
So if you apply force like this, it's really strong. But if you apply force across a layer, it'll come apart really easily. So what we've seen is that 3D printed plastic, depending how you apply force, is not as strong compared to traditionally made plastic. That being said, if you don't have any other options, you're still going to go with the weaker plastic.
I understand. So it's like, okay, so it's like a substitute,
Right.
which is not perfect. Like using cutlery made of metal and cutlery made of plastic. It's
Right.
like sort of the same, but not exactly the same
Right, it's
thing.
not going to be as strong. So there are ways you can get around that. Sometimes you can do some design modifications.
Okay.
So if you thicken, you know, the 3D printed plastic object,
Yes.
you know, it'll be stronger. If you, depending the way you orient the object when it's printed, you know, could also impact, you know, help make it stronger when you're using it. So there are different ways, but it's important to recognize that there are limitations to it. It's not a perfect technology.
Mateo, you guys okay?
Let me just answer that. So yeah. Hey Mateo, it's Julie in the Green Hab. Yes, we're A-okay, just filming some stuff.
Sorry for the interruption. I'll check in about half an hour, I guess.
No problem. Thank you very much.
Okay, so there's limitations to that. Okay, let me explain to
Sure. Do you want me to
yes.
put this back for you? Now you're all
It's
confused.
okay, I will explain. Więc zasada drukowania w 3D, tutaj zapytałem się Julii, czy są jakieś w ogóle wady, czy to jest technologia, która po prostu jest tak cudowna, że już nic więcej nie trzeba tutaj nad nią pracować. Otóż Julie mi powiedziała, że drukowanie w 3D to jest przede wszystkim nakładanie warstwę na warstwę. Mamy tu głowicę, która po prostu tworzy jedną warstwę, następną warstwę i tak się tworzy obiekt, który jest wydrukowany technologią 3D. Jest to tak zwane nakładanie adytywne. I teraz, jak to Julie powiedziała, jeżeli będziemy naciskać z tej strony, konstrukcja jest bardzo mocna i bardzo stabilna. Jednak wystarczy, że nacisnę z tej strony, no i cała budowla się rozpada. I tak samo jest z obiektami, które drukowane są w 3D. Mają one swoje wady, nie są tak mocne jak oryginalne przedmioty.